I think we can start with our session 3. I hope everybody had a chance to take a short break. So session 3 is, the theme is agriculture, and we have 3 presenters here. Dr. Rahman and I will be moderating this session. So we have our first presenter, Pritisha Patgiri, who is going to present on new protocol for P estimation in organically managed acidic soils in Meghalaya region in India. So Pritisha,
Yes,
you can share your slide.
Hello, ma'am. Am
yes.
I audible?
Yes, you are audible. Yes.
Okay, ma'am, let me just quickly share my screen.
Okay.
Ma'am, is it visible?
Yes, Pritisha, it is visible.
Okay. Ma'am, shall I start?
Yes, Pritisha, you can start.
Okay, thank you, ma'am. So a very good morning, good afternoon, good evening, everyone. First of all, I would like to thank the organizers, respected moderators, and the entire team of this HPRC. I'm very privileged to present my research work in front of all the great personas present today. Thank you for giving me this opportunity. So I attempted to develop a new protocol for phosphorus estimation in organically managed acidic soils in the state of Meghalaya, India. The study attempts to develop a quick and easy phosphorus testing protocol to get an idea of the actual soil phosphorus level in an organic farm so that the farmers can actually decide the amounts of organic phosphorus inputs desired for their maximum production and desired cultivation. The importance of phosphorus in the life of a plant is known quite well. So being a macronutrient, it is involved in disease resistance, root development, contributes to grain formation, and it is also known as energy currency as it forms ATP and many more. The deficiency lead to improper crop growth and yield, and the income of the farmers is hindered. So now we know how vital phosphorus is in the life of a plant. Broadly, phosphorus has 2 pools. The inorganic pool comprises of the solution phosphorus inorganic, labile inorganic phosphorus, primary and secondary minerals, whereas the organic pool comprises of the compounds such as inositol phosphates, phospholipids, nucleic acids, etc., which are quite stable products. Plants generally take up phosphorus in orthophosphate forms, and both the primary and secondary orthophosphates are dominant in the neutral soil pH around 6.5 to 7.2, however, towards the acidic side, the dominance of primary orthophosphate is quite evident, and towards the alkaline side, the dominance of secondary orthophosphate is quite evident, say at around more than pH 7.2. Meghalaya is a state of northeastern hill region of India, connecting Himalaya, we can say, and like any other states of the region, Meghalaya is also blessed with a lot of rainfall. Because of this high rainfall, soil acidity is quite a common problem in the entire northeastern part of India, including Meghalaya, and farmers suffer a lot for this. Phosphorus remains basically fixed in acidic soils. Also, in the previous slide, I already discussed about the role of pH on the availability of phosphorus for plant uptake. Again, coming to organic scenario, a different nature of nutrient status is evident as compared to the conventional farming soils. The conventional P extractant, which is used to extract the phosphorus in acidic soils is the Bre1 extractant, and we all are aware of it. But the problem in acidic organic soil is that the Bre1 extractant is not equally efficient in extracting the potentially available phosphorus. It is different in an organic farm to that of the conventional farm. The meaning, what I want to say is that the conventional soil testing methodology cannot explain the correct status of phosphorus in an organic farm. Therefore, the need of the hour is a different extractant, is a different and efficient extractant which can suitably extract the potentially available inorganic phosphorus in an organic production system. With this background, to carry on the investigation, I formulated 2 objectives. Number 1 is the identification identification of suitable organic acid extractants to extract the potentially available insoluble inorganic P pools in acidic soils under organic farming system. And number 2 is the developing a ready-to-use soil testing protocol for potentially available phosphorus dedicated to organic farming. So let us quickly skim through the experimental details, and then we will be proceeding towards the results simultaneously. So I selected 5 different sites of basically 2 soil orders, the insectisols and alphisols. 2 sites were conventionally managed, the farm of CPGS AS Umiam and a farm of Palvi village of Bhorangbong block of Meghalaya. On the other hand, 3 organic sites were selected. The sites of Palvi village and Kirdam village belong to alphisol order, and the rest are insectisols. 5 different organic acid extractants as elaborated by soil phosphate solubilizing microorganisms were employed against the conventional Bray1 extractant as check. The main idea is to mimic a scenario which is continuously going on in the soil ecosystem of an organic farm to extract and solubilize the insoluble inorganic phosphorus, which is later on taken up by the plants to fulfill their P requirement. The extractants were citric acid extractant, acetic acid extractant, lactic acid, double lactate extractant, and 2 ketoglutaric acid extractant. So 40 random soil samples were collected from each of the 5 selected sites, processed following standard procedures, and 6 composite subsamples were derived from each of the sites. Later, the soils were analyzed for their pH, organic carbon, available phosphorus, and total phosphorus following standard protocols. So these are the results obtained after the analysis, and the means of the parameters were compared using DMRT at 99% confidence level. And it is true for the extractants as well, which I will be showing in the subsequent slides. Coming to pH, we can see that the soils were strongly acidic, and it tends to buffer as the organic carbon tends to increase, as depicted in the soil organic carbon row, that is the second row. Of course, the organic carbon will be naturally high in organic farm. As mentioned earlier, the last 3 farms were organically managed. I already mentioned about the available phosphorus, that since the soils are acidic, it will be remaining very low. It will remain fixed. In fact, we can see in alphisol soil, the Palvi village, we can see how significantly low the value. It is just 11.1, just 11.1 kg per hectare. Now, talking about total P was found to be higher in organic soils as compared to the conventional soils. And these are the graphs of all the 4 results, which I discussed just now. So this are the extractants. These are the composition of the selected extractants. So these are the results of the extractants that I used, the 5 different. Of course, there are many other extractants, but I selected these 5 extractants. The size of P extracted by acetic acid was found to be significantly higher in organically managed soils rather than the conventional soils, in relative to the conventional soils. However, the size of this particular pool is relatively smaller as compared to all other pools. A relatively good size okay, so I have presented the data in the form of graphs as well. So you can see easily the difference of the data in conventional and organic farming systems. So coming to citric acid soluble P size, a relatively good size was evident under organic soils. Talking about lactic acid, not much difference could be seen in organic and conventional soils. In fact, it can be seen that a lower size of soluble P was obtained in the organic soil than that of the conventional soils. In case of double lactate soluble phosphorus, significantly bigger sizes of double lactate soluble P was identified under organically managed soils than that of the conventional soils. Among all the other extractants, the 2 ketoglutaric acid represented enormous volume of potentially available phosphorus in organic soils as compared to the conventionally managed soils. In fact, this particular pool is the highest extractable phosphorus pool when all other extractants are compared. For objective 2, the data generated were subjected to multiple linear regression analysis with total P as dependent variable. The relationship of total P, organic carbon, and all other extractants along with the check extractant was individually determined. Then the relationships considering all the possible combinations of extractants were identified. The stronger relationship will give the suitable extractant. So this is the table of regression equation which I obtained. Actually, I developed the equation models for all the individual extractants and all the combination of extractants mentioned in the previous slide. But I have presented here only those which had the highest R-square values along with the check. So the highest R-square value was obtained for citric acid. When I go for individual check of the extractants, and we can say that this particular extractant works best to define a variation of total P in organic soil. And then the second position was secured by double lactate extractant with R-square value of 0.62. In the third row, we can see how low the value of R-square is. That is a very, very poor relationship was obtained among total P, organic carbon, and Bray extractable P under organic farming system. And in the last row, the regression analysis revealed that citric acid and double lactate extractable phosphorus together along with organic carbon were able to strongly define the variation of total phosphorus content in organic soils. That is 93%. The value of all other combinations were lesser than this, and hence I did not present in the table. So these are the graphs depicting the equation of the previous slide. And
can you hear me?
Yes, ma'am.
Yes, ma'am. I just want to say, can you wrap up because we are out of time?
Yes, ma'am. This is the last slide only, ma'am.
Okay.
Yeah. So these are the graphs of the previous table. So this is the last slide, and I just draw a short conclusion out of my work. And when analyzed the relationship, we saw that citric acid and double lactate extractants could be claimed to be suitable extractant to explore the potentially available phosphorus. And this is something the conventional Bray-1 extractant cannot do under organically managed systems. Hence, before prescribing any phosphorus dose through organic sources in acidic soils under organic production system, it is advised to test the soil for potentially available phosphorus through citric acid and double lactate extractants for a successful organic production system. So this is the end of my presentation. Thank you so much, everyone, for your patience. Thank you so much.
Thank you, Pritisha. We have our next presenter. I'm not sure if I'm pronouncing the name right, so if I'm not, apologize. We have Galey Rinchen from Bhutan. Galey, I see you here, but I'm not sure if you can hear me.
Yes. Can you hear me?
Yes. You can start. Yes, you can share your screen, and you have 10 minutes again, just to remind.
So is it visible?
Yes, it is visible.
Okay. So hello, everyone. I'm Galey Rinchen, and I recently completed my bachelor's degree in agriculture from College of Natural Resources, Bhutan. And thank you everyone for having me here. I conducted an experimental research on production evaluation of altitude rice varieties at Dogar, Gewog, Paro, Dzongkhag. And this is my presentation outline. So coming to the background, in Bhutan, rice is considered as the most important food crop, and due to its pivotal role in the Bhutanese economy and diet, it is naturally termed parallel to the food security of Bhutan. And the per capita consumption of rice is around 150 kg per year, which is quite a large amount. And in terms of the dietary energy supply, rice contributes around 1,481 kilocalorie. And now moving on to my rationale, the need to carry out my research has risen from these facts. Number one, the Department of Agriculture has reported decline in both area under rice cultivation and its production from year 2010 to 2020. And secondly, the need to increase rice production in our country stems from the fact that we are only around 47% self-sufficient in terms of rice, and imports account for nearly 53% of the rice demand, which could put our food security at risk. And rice sector in Bhutan is also under potential threat from climate change and pest outbreaks, such as drying up of water resources and erratic rainfall patterns, and blast outbreak that occurred predominantly in traditional varieties. So therefore this, yes.
Just cross-checking one thing. Are you still on the first slide? Because we are all just in the very first slide.
Okay, I'll move on. So these are the objectives of my research: to evaluate the production of released high altitude rice varieties under high altitude rice growing regime. And yes.
Can you tell what slide you are on currently? Because we are not seeing, we are still seeing the very first slide.
I'm on slide number 5, madam.
Oh, we are still seeing the very first slide where you have your
How is that? Is it visible now?
Yes, now we can see the fifth slide.
Okay.
Okay.
I have presented the rationale and objectives. And now I conducted this research in a small village called Isuna under Paro Dzongkhag, and it was conducted in one of the farmers' field. And the trial was laid down using a RCPD setup with 3 replications. And soil analysis was conducted twice before transplantation and after the harvest. There were 9 treatments in total, including the standard check Janam. Yes.
Galey, I'm so sorry to interrupt you so many times. I'm still seeing the fifth slide. I'm not sure. I think you have moved past the fifth one.
Ma'am, can you play the slides for me so it would be more convenient? I think we have a problem here.
Yes. 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 Okay. Let me see if I can share it.
So I'll stop sharing my screen.
Yes. Yes. Thank you. And sorry about this.
It's okay.
For interrupting you.
The next slide. I've presented this one too. Oh, please stop here. So can I carry on with my presentation?
Yes, please. Yeah.
Yeah. So there were 9 treatments in total, including the standard check Janam, which had a long history of agroecological adaptation to the chosen study site. And the nursery raising was done in 2nd week of March using a dry bed method. And the transplantation was done in June at plant to plant and row to row spacing of 20 centimeter distance. And there were 250 seedlings in total in each replication plot. Next. So intercultural operations such as irrigation and hand weeding was also provided regularly as practiced by farmers in the village. So this research was conducted at the farmers level management. Next. And the trial was harvested from an area of 5.4 meters square after removing the borders, that is according to the standard guidelines provided by IRI. And the sample population consisted of 405 plants. And the quantitative traits on which data were collected included plant height, effective tillers per hill, days to 50% flowering, and etc. You can see here. Next. And at the end of the experiment, when the rice plant attained their full maturity, a farmer's field day was also conducted where they were made to rate the rice varieties based on their preference, giving different scales which were given different scores for further analysis. Next. And the data was analyzed using SPSS, Microsoft Excel, and Statistics 8. And the statistical tests performed included one-way ANOVA, cluster analysis, and Likert scale analysis. Next. So here are my main findings. In terms of plant height, the tallest plant height was recorded in Janam, and the shortest was recorded in Sasanishke. Plant height is an important crop component from a farmer's perspective when choosing a variety for adoption. And in our country, the researchers have found that the ideal plant height for Bhutanese farmers are above 100 centimeter. And in the current study, except for Sasanishke, all of the varieties evaluated had their plant heights above 100 centimeter, making them ideal for Bhutanese farmers. Next. Next. And effective tillers per hill, it is also an important crop component that is directly related to yield, and the highest number of effective tillers was recorded in Sasanishke, whereas lowest was recorded from Chananat 1 in Nisre Cup 3. Next. And yes, according to the standard evaluation system of IRI, all of the varieties evaluated were medium tillering. And moving on to days to 50% flowering, the standard check Janam was the first to attain days to 50% flowering, whereas Yusre Katramata took the longest duration. And similarly, Janam was the first to mature, and Yusre Katramata was the last to attain days to maturity. So the early maturity of Janam could be associated with its earliness in attaining days to 50% flowering, and researchers have reported that days to 50% flowering is a key indicator of maturity duration. And the panicle length, the longest panicle length was recorded in Janam and the shortest from Sasanishike. And the panicle density, the highest panicle density was recorded in UCRA Cup 3 and the lowest from Bug 20. And coming to the number of empty spikelets, the highest was recorded from Janam and the lowest was recorded from Khangmama and UCRA Cup 2. The high number of empty spikelets in Janam could be due to incidents such as it was observed during the trial that during the dough stage of rice maturity, Janam plots were heavily attacked by birds, which resulted in a high number of empty spikelets. This incidence was, however, not observed for the rest of the varieties. Next. And in terms of grain length, Yusre Mab 1 had the longest grain length and the shortest grain was recorded in Yusre Katramatra. And in terms of grain width, the longest grain width was recorded in Yusre Katramatra, and Janam had the least wide grain. And coming to the 1,000 grain weight, Yusre Cup 3 had the highest 1,000 grain weight and Janam had the lowest. And now coming to the yield part, which is an important crop yield component. The highest Sasanishke had the highest yield, although it had smaller grains and short plant height. It had a higher yield, and it could be attributed to having high number of effective tillers, as effective tillers is as I've mentioned earlier, it is an important crop yield component directly related to yield. And the lowest grain yield was recorded in the standard check Janam. It was heavy lodging was observed for this variety, and on top of that, it also had a high shattering rate, so which resulted in low yield. And coming to the straw yield, the highest straw yield was recorded in Yusre Cup 2, and the lowest was recorded in Yusre Mab 1. Next.
Galey, we are almost out of time. Can you please wrap it up?
Okay, so this dendrogram shows a similarity based on grain type, as you can see. Next. So the farmers feel the findings from farmers field they revealed that Yusre Cup 3 was the variety most preferred by the farmers due to its desirable traits, such as bigger grain size, average number of effective tillers in plant height, and it also had minimum shattering rate, which was suitable for farmers when transporting to threshing site. And Janam had the lowest rating from the farmers because it had heavy lodging was observed for this variety, and on top of that, it had low yields. So this was the least preferred variety by the farmers. So next. So here's my conclusion. The quantitative analysis showed that the other release high altitude rice varieties performed well compared to the standard check, and the result indicated that release varieties performed significantly better than standard check Janam in terms of grain yield, which in absolute values range from 2.1 to around 3.4 ton per acre. And the ratings by farmers showed that Yusre Cup 3 and Chananat 1 were the two varieties most preferred by the farmers of Snachok. And the genotype, here's my recommendation. The genotypic traits and the climate resilience of different rice varieties could also be evaluated for rice improvement in future. Thank you, that's all.
Thank you, Galey, for your presentation. So our last presenter in this session is Samantha Harris. Samantha, can you share your...
Yes. And then let me, where is the little presenting button? There we go. Okay. Can everyone see?
Yes.
Perfect. Okay, so hi, my name is Samantha, and I'm going to be presenting feasibility of an FFQ for South Asians living in the United States, and this is a pilot study, and this is out of New York University. All right, so a little bit of background. So the South Asian population is one of the fastest growing ethnic groups in the United States. There is a very large lack of research regarding this population. A lot of times within Asian, when they study Asian culture at large or Asian food, really South Asian tends to make up only 5% of the studies. Really, it's more focused on countries like China. And so therefore there's a very large lack of research, and they have found that there are higher rates of arteriosclerotic cardiovascular disease However, they have lower cancer rates. So there's a little bit of a dichotomy why that's happening. All right, so South Asian diet in the United States, there is a lot of dietary acculturation. So many South Asians who've immigrated to the United States have adopted eating patterns that are typically Western alongside traditional South Asian foods. So for example, they could have Cheerios for breakfast, but they're still having their chai in the afternoon and curries and a lot of dal and so forth. So there's a large mix of the two different cuisines going on. So there is a research gap. So why do South Asians have a much lower cancer risk in the United States, but higher rates of other things? So the current dietary assessment tool, which is called an FFQ, is geared towards a Western diet. So what typically happens is when there's a large enough ethnic group that has immigrated to the United States, they have created a FFQ that includes Western foods and that ethnicities' typical foods. However, South Asians have been the largest immigrant population for many years now, and there's still no FFQ. And so another, that is one of the reasons of this research. Another reason, we all know that there's lots of herbs and spices in South Asian cuisine, but like the scientific, we know that, but we presume there are benefits of the herbs and spices in their cooking. But there is not a lot of research surrounding South Asian health at all. And long story short, there's no culturally relevant South Asian food frequency questionnaire. The food frequency questionnaire is the tool that you take, is the dietary assessment tool that you take to see what food someone is actually eating. Essentially, you can think of it as like a quiz or like a bubble sheet, and you have to mark things off so you can see what food you're eating, what food you're not eating. All right, so what is SA-FITS? It is South Asian Food Information Technology System. That is the overall goal, and that is where this research comes out of. So it's a research group focused on creating and designing a culturally relevant South Asian dietary assessment tool. So alongside the food frequency questionnaire, which is the largest portion of SA-FITS, we are now in the 21st century. So we feel that instead of it being like a printout, which is very typical, we can use technology to make it interactive, and we can enhance it by incorporating short 24-hour screeners for specifics or something like pictures. So you can really see, hey, I think I'm eating 2 tablespoons, but really I'm eating 1/4 of a cup. So stuff like that. And a little bit more about this project. It is a multi-phased project. So I'm presenting information from phase 1, which is already completed, and it was funded by SEEPS, and phase 2 is currently ongoing. All right, so a little bit about the methods behind this project. So a sample of adults aged 18 years and older who self-identified as South Asians, and they were living in the United States, were recruited via email and social media platforms. Sociodemographic information, food shopping information, meal preparation, smoking, physical activity, alcohol consumption was collected on a Qualtrics survey. These are just very standard questionnaires to ask. And then a qualitative data was collected on one-on-one interviews that were performed with a 24-hour diet recall and home food inventory via Zoom. So really what that looked like is someone from the research team would be talking to someone who was recruited to participate in the study. And we would essentially go over what they ate in the last 24 hours in great detail. And then we would go, and as you can see this picture, we would go through every food item that was in their house. And one of the benefits of this being on Zoom is, as you can see these pictures, we can physically see what they had in their house, and we can see the brand, the quantity, you know, do they have a ton of spices? Do they only have 3 spices? Information like that. And then all of these information was recorded and transcribed for for analysis. But like, as you can see in the picture, someone is showing us their spices along with like prepared mixes and stuff like that. And then this little baggies fruit, you can't really tell, but that's just like a good look as to what we were seeing as we were doing these interviews. All right, so the results. So the average age was 29.8 years, plus or minus 8.6. Mostly female, and 91% had a bachelor's degree or higher. 65% lived in the Northeast region of the United States. 69% reported eating South Asian meals at home at least 3 times a week, if not more. and 85% reported always or very often using South Asian herbs and spices. So as you can see on this side, the biggest country of birth was the United States. However, we did have a range, and household income was pretty high in this study. And then another interesting part about the study that was because it was during COVID, people were visiting the South Asian market stores only once or twice a month. Many people in the study reported that their habits had changed drastically pre-pandemic versus current as we were doing the study. Some people still went, 3 to 4 times a week, but most people, it had gone down drastically. All right, so results. We gathered 484 unique food items, and they were organized into 12 different food groups, which consolidated into 302 food line items. And you can, for an example, like an orange and a clementine can share a line, stuff like that. That's why it was able to smush down a little bit. And the 12 different categories were beverages, dairy products, vegetables, fruits, beans, legumes and nuts, meat, fish and poultry, bread, cereals, grains, mixed dishes, desserts and sweets, miscellaneous and condiments, and then herbs, spices, seeds, and the last one was oil. And then as you can see on this graph over here, the example category is bread, cereals, and grains. And then within that, you have your different types. And then you say you click flatbreads, and then you have more flatbreads that you can pick within that. And this is the overview at large of the 484 food items in the 12 categories and every single sub item within that. So within the 302 line items, 215 are food items, 73 are herbs and spices, or I should say herbs, spices, and seeds. And then we have 14 fats and oils. And these categories at large were based off of the USDA food category ranking, as this is happening in the United States. That was our basis for these food groupings. And then conclusion, this pilot study demonstrated the feasibility of collecting dietary information and with the ability to create a culturally relevant food assessment tool. And specifically, we proved that it was possible to do it via Zoom. Next steps, which is part of phase 2, include validation of the food list with additional pilot groups to test intake frequency, item use, proper grouping of all these food items and so forth. And that is it. Thank you so much.
Thank you, Samantha. So I think, Rahman, would you like to go with the feedback first?
Hello, everyone. So yes, I will. Okay, do you hear me now?
Yes.
Okay, so I will go over the papers and we'll try to give some feedback. So the first paper that I will talk about Pritisha's paper that looks so nice, and like it's really important for organic farming there. So I have just like only one comment or feedback like on that paper. So when you were showing the at the very end, like all those regression analysis, you were showing the R square, right? So you had done like all the regressions and got the R square to show if you got a better fit for the extractant. Like so for some general like regression analysis, R square always suffers from the limitation of losing degrees of freedom. So that's why maybe when you got 0.93, you had like all the regressors there. So you had like 3 more regressors. That's why you got like a larger square. So I would say if you can look at it and report the adjusted R square, that would be a much better idea in this kind of scenario. And that can give you a precise extractant fit for your models. Other than that, like the presentation was really good, and like yeah, as I said, it's a really interesting topic and important for organic farming. Also, like I would want to add one more thing is like try to show some like social dimension of it. Like I would say like some policy analysis, like from your result, what can be done like in the future, or like how these results can be used directly in the field level. Like that's the thing I think you can add a little bit. So yeah, these are my 2 comments from it from this paper.
Rahman, maybe I can also add some comments. I mean,
Yes.
I have questions. I was interested to know whether these results are valid only for organic lands specific to Himalaya, or they are like representative of all organic lands. And also, I wasn't sure what were the controls in the regression equation, because nowhere in those, none of those equations had controls mentioned. So maybe can you like tell us about it?
Yes, ma'am. Ma'am, actually, it is valid for all the organic farming systems, because, ma'am, in almost all the farming systems, microorganisms play a better role, and the extractants that were chosen are on the basis of the abundance of the extractants in soils as released by the microorganisms, as well as their chemical properties. And ma'am, about the control, I would like to say that I have taken Bray1 extractant as the control, as a check, and with all other organic acid extractants, ma'am.
Okay, thank you, Pritisha.
Thank you so much, ma'am.
Rahman, I think we can move on to the next paper.
So yeah, I'll move on to the next paper, which is about that the analyzing the performance of rice varieties in high altitude. So yeah, I read that paper, and like I have like a few minor comments. Like if you can add that into your paper, that would be great. So first, I would say like why you have chosen that place specifically. Like yeah, like maybe in the paper you can describe it a little bit more. Like so what's the reason of choosing that place to do your experiment? That's one thing. Another thing is like, so when you are choosing that 9 traits to do your analysis, how did you choose that 9 traits? Like, did you get it from the previous studies, like from the literature review, or some like previous experiments that people have done, or like you have like so, or you have some other reasoning, like how did you came up of that 9 traits that you are using for that analysis? This is one. Okay, Galey, like you want to talk about it?
Can I answer?
Yeah.
Yeah. So I chose that particular place because the varieties grown in that particular place were mostly predominantly traditional, which are at higher risk of rice epidemics. And so that's why I chose. And moving on to the second question, I chose those 9 traits for analysis, and these are based on the guidelines provided by IRI for evaluating rice varieties. So those are based on guidelines provided by IRI.
Okay, yeah, great. Yeah, you can just like explicitly say it in the paper. That will make it much more clear. And the last one is like, so you have done the ANOVA analysis across your 9 traits, right? I don't know like if this adds much or not, but I think you can also do an analysis across your plots, right? So that's why you can see if you have some kind of variation comes along from the plots along into your or 9 traits for your 9 treatments. So yeah, by this way, like you can add some more analysis into it. And the last of all, like I would give some comments of the structure of the paper. Maybe in the introduction you can add one more paragraph saying like how did you like saying like your methods and your result a little bit. And one thing is missing is like I didn't see any thing written about the contribution of this paper in your field, like how you are contributing, like is it like theoretically, experimentally? So yeah, you need to, I think you need, it's better if you add that contribution part in your introduction, as well as like in the conclusion. I would say you can increase this a little bit and add some more policy analysis into it, like say how the farmers can be benefited if they take like these 9 varieties of high altitude rice, right? That would be that would give like a much better conclusion, and and the policy dimension of your study. Yeah. So yeah, these are like my few comments for your paper.
Thank you so much.
We can move on to the third paper. Do you have any feedback for it, Rahman? I mean, there's a lot of discussion going on in the chat.
Yeah, Yeah, exactly. I also see that. So I had just one question. I think Dr. Bohara has already asked it. Like, how did sampling was done for 66 people?
Yeah,
I,
so sampling was more of a convenience sample. We recruited people via email, listservs, and social media. So a lot of times someone would say be a member of a certain temple or a church, and we would email them, or people. There was at a lot of different universities, there are South Asian research groups and South Asian clubs in general. So we reached out to a lot of those. So it was more of a convenient sample more than random sampling, which is one of the weaknesses of phase one. And we are aware of that. And so we are hoping that as this study continues and as we eventually hopefully get to validation, we will be able to use more of a like random sampling technique, which we can get a little bit more valid, a little, I don't want to say more valid data, but not a convenient sample. However, we were able to reach participants from, I believe, 23 different states, including Hawaii. So we did have people from all over the United States.
So along with that, like I have just one more query. So do you think, is this a representative sample, like 66? Do you think like, is this enough, or like you should have some more samples? So yeah.
Yeah, so I think one of the biggest things that I need to highlight is that this is a pilot study. So the whole point of phase one was to see if it was feasible. And so we did prove that it was feasible to do. However, in order to get a valid FFQ, we do need a much larger sample size. Currently phase two is going on. And so that is not the data I presented on, but like we are moving on the next step. So 66 people was enough to prove that it was possible and it is valid. However, you know, at the moment we're working on like very small grants and so forth. And so before we get to the final FFQ and the final result, we will need much more people. But again, as I said, this is just a pilot study. So the whole purpose of phase one was just to prove that it was possible to do via Zoom.
I have some comments. So I was looking at the slides and I couldn't because I didn't have like a full paper.
Yes.
I couldn't really get the statement where you said current dietary assessment tools are geared towards the Western diet, and you put that in quotes. I want to know what gaps are this new tool or new instrument, as you would call it, would close.
Yes. Okay. So a Western diet, you think of like a very typical American diet. There's not a lot of herbs and spices at all. You know, a lot of breads and so forth. South Asian cuisine has a lot of, oh, and the one thing I meant to, sorry, going back, is the 66 participants. However, we did make sure to get someone living in the United States from every country. And so that was a big part of it, because within South Asian research, often it's very heavy Indian. However, there's more countries than just India. So that was another point that we are making sure to get someone from every country. Sorry, going back. The Western diet doesn't have a lot of herbs and spices. There's not a lot of lentils or rices or curries. That is not very typical in a Western cuisine. So this new tool will have both Western foods, for example, Cheerios, you know, cereal, but we'll also have things like your curries, your spices, your samosas, your teas, all of those things that if you ask someone who is, you know, 5th generation American, they probably are not consuming. And so this tool will combine both Western and typical South Asian foods. So the gap there is that there's not currently any foods in the dietary assessment tool that are South Asian. So you can't gather a accurate dietary assessment if it doesn't include half of the foods that someone is eating.
Right. Okay. And I have one small question.
Yes.
We're out of time. So what about like, are you accounting for people who have just moved to the States versus who have been there for years or decades, because their eating habits would change, right? Like, how are you? I don't think we can categorize both groups as South Asians, right?
Yes. So the requirements are South Asian living in the United States. So one of the questions we asked prior to doing the surveys, the one-on-one interviews, was what generation they were, because the tool itself isn't going to be given to just first generation or just fifth generation South Asian. It's going to be given to all and anything in between. So we are categorizing, as long as they're currently living in America, that they qualify for the study, but they have to self-identify as South Asian. So if someone has been living here for, their sixth generation, but they don't identify as South Asian, then they wouldn't be given this tool. So that is, it's, self-identification.
Thank you, Samantha. I have a couple more questions, but I think I'll ask you separately in the chat.
Okay, thank you.
Yeah, it's time for a 5-minute break.